Have any problem of earlier classes?
No, sir.
Himanshi Virmani?
Yes, sir.
Have you revised earlier classes?
Yes, sir.
Sarthak Jain?
Yes, sir.
You understood the earlier classes?
Yes, sir. But I, sir, missed the last class.
Yeah. Arjit Banik?
Yes, sir.
Are you understanding the classes so far?
Yes, sir.
Good. A very good morning to everybody.
Good morning, sir.
Last class,
Morning,
it
sir.
was an introduction of probability. Probability is a number. Associated to an event which is defined on a random experiment. So, probability we talk about coin, die, playing cards, marble, customer. In reality, the objective changes. Your random experiment changes. So from today, you are going to learn different type of probability evaluation in the sample. Probability evaluation in the sample. I would like to do two distributions today. Binomial distribution and normal distribution, if time permits. You have to ask doubts, difficulties. Then only it is interesting to learn subsequent classes. So let me share with you module 4. Histogram for learning probability distribution I will do afterwards. But what is binomial distribution? There are various assumptions. Your sample size is fixed. Each observation is independent, like marks obtained by one student is independent of marks obtained by another student. A customer comes to the shop to buy a product, nothing to do with another customer. This is what we call independent. Each observation is represented as success or failure. I go to the market to buy a shirt of my choice. That is success. But if I go to Park Avenue, maybe I will get it or I will not. Failure. Probability, therefore, success be defined P and 1 minus P will be failure is a fixed notation. Any notation you can use. But as far as the classes are concerned, P represent probability of getting success. 1 minus P is probability of failure. How many successes? That is X in a sample of N. And probability evaluation is NCX, P raised to X, 1 minus P to the power N minus X. This is the probability model in these assumed assumptions in the sample. Out of N, X are successes. So probability will be P raised to X. Remaining N minus X are failures. So it will be 1 minus P to the power N minus X. Yash Mehra. Dev Pandey.
Yes, sir.
Do you follow this assumption?
Yes, sir.
Simran Pahuja.
Yes, sir.
Do you follow these 6 assumptions?
Yes, sir.
Meaning, repeating. Wherever you have the selection either favor you or not favor you. and you are observing a sample of n outcomes. Evaluate probability of favoring you in the sample. Binomial model. These are the 6 important syntax that we are going to use in R. B binom, carefully see in the bracket, x comma n comma p, B binom, x comma n comma p, Q binom, probability n comma p, R binom, sample size comma n comma p. So to explain this binomial distribution and R, consider the first example. State the probability of 0, 1, 2 successes on 6 independent trials where the probability of success is 0.3. State the probability of 0, 1, 2 among 6 trials where probability of success is 0.3. So P is 0.3 and 1 minus P is 0.7. N is 6. X is number of successes among 6. That is 0 to 6. Six customers. Success means prefer coffee. P means probability that a customer prefer coffee. And X is number of customers preferring coffee is a counter example. So the sample of customers is 6. Sample of customers is 6. So let me start with R package. In this example, all the assumptions are there. All the assumptions are there. Evaluate the probability in the sample is my work. N is 6. 6 trials. Trial means customers. Probability that customer prefer coffee, success. And you want to evaluate the probability for 0, 1, 2, 6. So my variable here x will be possible values. So probability for binomial distribution, I denote by BD. Is B binom X is the syntax. This is the syntax. B binom gives individual probability in the sample. How? Let us see the output. Look, city will be 1. Third probability for 2. Fourth probability for 3. Fifth probability for 4. Then 5 and 6. And we want probability for 0. I denote P0. P binom 0, 6.3. I want probability 1, P1. P binom again I want P2. This means individual probability for 0, 1, 2. Finished. This is what expected in the first example. This is what expected in the first example. Any question? Yes, yes, yes. Binom stands for binomial distribution. And D stands for distribution. And distribution means individual probability. I am observing a sample of 6. And my successes are 0, 1, 2, 3, 4, 5, 6, denoted by X. And probability of getting success 0.3, probability of getting failure 0.7. Asking, compute probability of none of the successes, 1 success, 2 successes. The binomial x comma 6 comma 0.3. That is the syntax. That is the syntax. I have written also the binomial gives individual probability in the sample. Let us see next question. Exactly 3 are perfect, exactly 4 are perfect, 3 or more are perfect. So in this example, the event is perfect drill among the sample of 5 locations. Among the sample of 5 locations. Hence, I will be having sample of size 6. So my x or xy, any notation you can use to make a change, I denote it by x1. This is my perfect drills. This is my perfect drills. I denote probability for binomial distribution for second question. The binomial x1 5.95. I have the probability. I have the probability. Let us see how the answer is. Got it. Probability for 0, probability for 1, probability for 2, probability for 3, probability for 4, probability for 5. One more probability I can define, and that is cumulative probability of binomial distribution for second question. This stands for cumulative. And the syntax will be P binom x1 5 0.95. Let us see what is the answer. This is addition. First is for x1 equal to 0. Second probability will be for 0 and 1. Third probability will be for 0, 1 and 2. Fourth probability will be for 0, 1, 2, 3. Fifth probability will be for 0, 1, 2, 3, 4. And the last is the total probability. So two functions you have learned. Two functions, B binom and P binom. The P binom gives cumulative probabilities. Two functions you have learned in binomial. And here we want, in this question we want exactly 3, exactly 4, and 3 or more. So in this question, PA, first probability will be exactly 3, which means D binom. And the next will be PB. Again D binom 4, 5, 0.94. And PC will be probability 3 or more, which means 1 minus P binom 2, 5, 0.95. PA, PB, and PC. Total probability will be 1. From 1, subtract the lower probability up to 2, you will get 3 or more. Let us see the answer. Yes. This is question number 2.
Excuse me, sir. Please explain the syntax of PC.
This is question number 2. Karthik Mittal.
Yes, sir.
Do you follow all the evaluation?
Yes, sir.
Kanika Goyal.
Yes, sir.
Do you follow all the syntax?
No, sir. Can you explain PC once again?
Yes, I will do. Rohit Podar.
Yes, sir.
Clear the computational technique?
Yes, sir.
Okay. I repeat again. You have given 5 locations for drilling. Success means the drill is perfect for oil with probability 0.95. Understood. It is a binomial technique. Asking exactly 3 are perfect, exactly 4 are perfect, or 3 or more are perfect. D binom and P binom are the two functions I have used. And for 3 or more drill are perfect, it is 1 minus up to 2. Up to 2. The alternative way to find PC. Different way. From P binom P to 4, 3 to 5, 0.95. Alternative way, another way. Add up the individual probability from 3, 4, 5. See the answer. Same probability. Same probability you are going to get. This is question number 2. I'm going slow. Any syntax, if you don't follow, you have to ask and get
Sir,
it
one
clear.
doubt.
Yes.
Sir, when we read this syntax, it will be the item for which we want the probability, comma, the number
Comma
of...
3 double colon 5.
Yeah, no, yes, sir. Yeah, after that.
After that, 5.
5 is
5
the
stands
number
for
of
sample
item,
size,
and then
and
the
P
probability
stands
of,
for 0.95.
which is the probability of successes.
Yeah.
Okay, sir. Thank you.
So 3 is to 5 is accumulation of 3, 4, and 5, right? Over here.
D binom. I will be using D binom.
So I'm talking about 3, like 3 and 5 over here. So what does that suggest?
What is?
3 is to 5.
Who is asking that?
So Bhavya Patel.
Yeah. What is the parameter? Which one?
So PC1. In PC1, you have written D binom 3 is to
If
5.
PC is less than 1 minus.
No. The PC1, the second one, the last one.
PC1.
Yes, sir.
That is alternative probability for PC. Another way to find the probability.
Okay. Thank you, sir.
Another way of finding the probability for 3, 4, 5 addition. Okay. So, so let us see the next question. Very simple probabilities we had. Now let us see the next question. Suppose 4 students each have about 80% average in the course so far. That is, probability that a student get a better average is 0.80. Assume that probability of maintaining or improving the average is this number 0.8. What is the probability that all 4 will maintain or improve their average? This question I put in notation form. This is for 4. Suppose if I modify 10 students, X is the number of students show improvement among a sample of 10. Then I can find this way the probabilities. So let us complete first 4 students probability. Then we go for 10. So repeat R. Now I will be going for question 3.
Sir,
Yes.
sir, I have one question before you move forward. Can you please explain PC1 once again? Why have you written 3:5? Like, what does it
PC1
suggest?
is sum of the probability D binom, not P binom, 3:5. मतलब 3 to 5.
Okay, it's a 3 to 5,
5,
3, 4, and 5.
3:5, comma. 5 is my sample and 0.95 is the probability of success. And parenthesis closed.
Okay, sir, thank you.
So in Q3, suppose I denote 5. I have only 4. I have Y binomial distribution probability. This syntax. And I have the probability. Zero, 1, 2, 3, 4 probability. And our answer will be for all of them are improved. So answer will be 0.4096. P4, I denote. Or any variable you can say. Answer for 4. P binom 4, 4.8. You can verify. You can verify. Suppose if I take instead of 4, 10 students. My variable I denote y1 c bracket these many have chance of improvement. So the probability distribution for this variable binomial is, again, you can talk B binom. Look, 11 probabilities you will get. So in this, the very first probability will be 3 inclusive 7. Three inclusive 7. So I denote the first probability PY1. Sum P binom P 7 10 comma 0.8 is the syntax. Minimum 3 and the maximum 7 students out of 10. The second case greater than 8. Greater than 8 means 9 10. Sum B binom bracket 9 to 10 and 0.8. And x less than 9. Sum B binom 0 to 7 because less than 9, so 8.
So can we use p binom here?
B
Yes,
binom.
sir. I had the same
B by
question.
third answer.
Sir,
Sum less than 9, that means 0 to 8.
sir,
Uh,
can we use p binom here?
D
Cumulative.
binom.
No, can we use p binomial?
If you use P binom, I will show you.
Okay.
Sir, I guess you use the two brackets in
We can
P.
work the same way for P binom. I will show you.
Sir, I
So
guess
let me
you
see
use
that.
two brackets in PY II.
Yes, somebody asking me.
So you use two brackets, I guess. After D binom in the second one.
Are you asking about the PY1, PY2, PY3?
No, sir, no. I'm just asking if you have used two. Why did you use two brackets after D binom?
After I will show you how to work with P
So
binom.
I think there's a syntax error in the second PYII where you use two brackets after D binom.
Yes, that's what I'm asking.
It is I means second part.
So there's an extra bracket.
Sir, in
So there's
PY,
an extra bracket.
Close the bracket.
Let us
Sorry.
verify. Let us verify. Error. Okay. Okay. Syntax error.
So you have to define it as well, no? Py.
One. I say PY2.
Sir, you have used an extra bracket. That's why the syntax error is there in PY2.
Let me see. Yes, a double bracket is here. That is one more error.
Yes,
and
sir,
I
that
will
is
write
one.
here PY3 also.
So even pyi would have worked, sir.
The answer I'm not getting now. I have to print
Sir,
out.
because you haven't defined it. Because
Let
you
me
haven't
see.
defined it afterwards, no, sir.
So you have to
Let
call.
me see.
I guess that's what.
PY1,
Yes, sir.
PY2, PY3.
This you haven't done in the I case.
Yeah, it's the same thing you can get. My error was a double extra bracket. Answer I got. Let me verify with the same thing in front of you. I have used the notation from the question paper. Same answer. Good, good, good. It was not an error of I, it was my error of extra parenthesis. Okay, so you found out here the probability evaluations of answer 4. But same way, you can use for P binom instead of sum. Exactly same answer you will get. For example, 3 to 7. 3 to 7. Which means 0, 1, 2 not expected. 8, 9, 10 not expected. So I can write down my algebra for P binom. Say Py. Instead of I will be using some other notation. Say small a. Three to 7. So P binom 7 and 0.8. So this will give me cumulative probability from 0, 1, 2, 3, 4, 5, 6, 7 minus P binom I want 3 inclusive. So I don't want 2. 0.8. Next, PYB, second part. I want the probability more than 8. That means 9, 10. So this is 1 minus P binom more than 8. So 8 I don't want. This is the probability. And the final, it is up to 8, inclusive. So PYC P
Sir, then it should be 10 comma 0. 10 comma 0.
It is comma. We don't want 9, 10. We want up to 8. Let us see the answers. Same answer. Same answer you got. Same answer you have. Therefore, D binomial P binomial and sum helps to evaluate various probabilities. In this one example, my class is of 10 students. Probability of improvement 0.8. I want to plot the probability. Already in correlation regression, you have learned how to plot scatter diagram. So in this case also, I plot y-axis will be my probability binomial distribution and x-axis will be by variable y1. I got a graph. So the graph shows smaller the probability of improvement increases coming to a higher number and decreases. The red points are probabilities. For every possible values. So, a small introduction of binomial distribution for evaluating probabilities I have shown. Little higher level I have to give now. Any question?
So what was that explanation for the graph you said, like the smaller the value?
Yes. Graph says smaller the probability for smaller value of y and higher the probability for higher values of y.
Okay, sir.
In x-axis, As y1 increases, probability also increases. So what I have used was nothing other than simple syntax for evaluation of different probabilities and the graph. In the question paper, this is what I have shown, 3 questions. The number of students are plenty in the institute. Suppose if I choose 50 groups of 10 students, what is the sample value of X? Do you follow the objective? If I choose group of such 10 samples, $50 samples means how many students?
500.
Huh? If I
500.
choose 50 samples of 10 students from the institute, how many students I am choosing?
500, sir.
500. Asking you, generate a sample of X. That is, in each group, how many have higher chance of improvement? Every one of you get different answer now. Everyone, even me, you, because samples are different from person to person. So, let us see how to generate a sample now. I'm going to explain you sample selection. From repeated binomial distribution. Which means 50 times group of 10 students each. 50. This is the meaning. So I say my answer per group. So in each group, there can be number of students possibly improve. How many for each? That is random sample. Or binomial 50 10 0.8. Let's see how many. In the first group, 8 have improvement possible in my sample. In the second, it is 9 and so on. In the 50th, it is 9. So arithmetic mean I can find sample mean. I can get the average 8.22. Sample standard deviation. How many of you got nearly 8?
Yes, sir, I got 7.9.
Yes, approximately 8. And if you find out, listen carefully.
Excuse me, sir, it won't be the same because we will generate different samples.
Cannot be same, but I say closer to 8.
Yeah, it will be around that value.
Yes, around 8 you have to get. So this means sample mean will closer to NP, and NP equal to 10 multiplied by 8, that is equal to, or 10 multiplied by 0.8 is 8. And
So will the
sample
sample
error.
standard deviation also be different?
Really, what I say, exactly 8 may not be possible.
Yes, sir, I got that. But
Yeah.
sir, my
If
question,
you get exactly 8, it is okay.
no, my question is the sample mean will be different because we have different samples.
Different sample, it will be differ
so
from
will the
sample to
sample
sample.
standard
Let us wait,
deviation also be
let me complete. So sample error is equal to difference of sample mean and NP. In my case, sample error is 8 minus 0.22 becomes 0.22. How many of you got in decimals the sample error?
Sir, I got minus 0.02.
Yes. Anybody got more than one? No. Next. Sample error is closer to square root of NP 2 means 1 minus P. That is, standard error will be SQRT N, that is 10, P, that is 0.8 multiplied by 0.2. Let us see what answer we will get. $1.264911. Square root of 10 into 0.8 into 0.2. If your sample error is below this number, your analysis will be closer to population parameter. Error, like in correlation regression, if your sample standard error is smaller than theoretical error defined by the parameter, you are approaching to better result.
So can you please repeat this line?
Yes. Look, my interest is to explain you sample concept. How much error of analysis possible in my sample? So to explain this, I say, if I go for repeating the sample of 10 students in the institute, say 50 times, these are my sample data. And in the sample data, the mean 8.22 with an error 0.22. So my sample mean is near to 8. 8 is the mean defined by the parameter n into p.
Yes, sir.
But how much is the sample standard deviation? I got in my sample it is 1.03 and that is theoretically defined as square root of NPQ. So sample standard deviation is less than the theoretical measure. That means I am approaching for a better result in analysis. I am approaching for a better result in the analysis. Suppose if I repeat this 100 times, instead of 50, say 100 times. Let us work out. 8.13. And the sample standard deviation is 1.353. And theoretical standard deviation is 1.264911. What happened to the mean? What happened to the mean? Anybody got sample mean much nearer to 8?
So mine got more distant. I got 7.94 in the
How much
first
you got
one.
sample mean?
The first time it was 7.94. Now it's around 8.19.
How much?
8.19.
8.19, correct?
Yes, sir.
So the deviation is 0.19.
Yes, sir.
How much is the sample standard deviation?
So 1.19.
Yeah. So it is higher than the sample standard deviation by the formula, correct?
Yes, sir.
So let me reduce now. 100 becomes, say, 70. I'm defining 70. 70 as my random sample. Yes, how much is the error? Sample arithmetic mean error will be, for me, it is 0.15. And sample standard error will be smaller. So this demonstration I have shown 50 times, 100 times, 70 times. Tells what? Anybody? Anyone?
Pardon?
I am repeated 3 times. First I computed for 50 times. Next I computed for 100 times. And the third time I computed for 70 times. My answers are varying. For 50, my error was 0.22.
Sir, as the sample increases, the error decreases, I guess.
So what it tells then?
The bigger the sample size, the smaller the error.
Yes, determine a sample size where my analysis have lesser error, correct now?
Exactly, sir.
Determine.
More precision.
Yeah. Determine the sample size for which my error will be smaller, because theoretically I got 8 as the mean, 1.26 as the standard error. So I have to find what sample should be selected from a binomial population to get smaller error. So for various n, capital N, I can find both and determine how much closer will be my sample to parameter.
Sir, how will we decide what should be our sample size?
Yeah, that
Exactly.
is what I say. 50. Suppose, see, initially what happened? I have selected 50. I have selected 50. So what is my sample mean and etc.? So my sample mean will be 7.6. So error will be 0.4. And sample standard deviation is 1.22. And the error defined by the formula will be 1.26. So for 50 in my sample, standard error will be smaller than that of standard error defined by the model. And error of the sample mean will be 0.4. It's okay. Let me check now. If I increase 50 to 70, what happened? 8.125 and sample standard deviation increased. But in case if I go for 70, in case if I go for 70, I got very less mean difference and very small standard deviation. So which sample size you will choose for analysis? Is it for 50? Is it for 80? Is it for 100? Or is it for 70?
70.
Why? Because our error of analysis has to reduce. Arithmetic mean is 8 and sample mean is 8.08. So my error will be 0.0. So as your sample size detect how much closer are your analysis and how much error, sample size has to be determined. And to determine the sample size in a binomial model, the syntax will be R binom, sample size, and individual sample and probability. R binom. Now, let us see attentive. I have here sample. Attentive, I have here sample. I already represented plotting of probability. Same way, I can plot histogram for the sample data. I can plot histogram for the sample data. And histogram is a graphical representation of X values in sample. Say histogram. Histogram, that is HIST, and my sample data, comma, color. Let's see, am I going to get the graph? What does it mean? In my sample, do I have value 0, 1, 2, 3, 4? I have generated sample. 70 samples I have observed. In all the 70 samples together, do I have value 0, 1, 2, 3, 4? What is the minimum value in my sample?
Sir, 5.
And maximum?
10. 10.
So in your sample also you can have histogram. And if I plot a histogram for the sample, I will get an idea which value repeated more time, which value repeated less time, which value not repeated. Say for example, I increase to 100. This demonstration is for histogram. As my sample size become 100, what happened to my histogram? Because you also get similar histogram, but the question here based on my histogram. Anybody?
So we are getting 3, 4 also counted. Like,
but lesser.
3, 4 was not there.
Lesser. Higher the number will be 6, 7, 8, 9, 10, isn't it?
Yes, sir.
Yes, sir.
Yes. So when you generate the sample from probability models, or when you collect the data from a real model, you can definitely plot a histogram to check how concentration is your value. Can anyone? In the class earlier, another way we can talk about concentration, which was it? Which was it? Table and sample. We have prepared tables in the last class. See? See, another way of working. A table which we already learned helps us to draw histogram as well. In the table, you are classifying the data represented. In histogram also, you are classifying the data represented. Probability also tells you the data represented. Probability is also represented that way. Look now, all the three I will explain. D binomial, that was our earlier work. That was our earlier work. Look, 10 probability. For smaller the value, smaller probability. As increases, probability also increases. 8, 9 probabilities are very high. And 10. And that is what represent in your sample also. That is all represented in the sample. Look now. 3, only 1, very small probability. 4, 5, very small probability. 5 is little more higher. 6, much higher. 7, more than that. 8, 9, 10, higher. And 11, little less. For 7, this is the probability. For 8, this is the probability. For 9, this is the probability. And for 10, this is the probability. So which frequency is high? 7, 8, 9. And the probabilities are also 7, 8, 9. So if I know probabilities, what you can talk about your sample before you go sample selection? Anybody? If I know probability of possible answer in my sample before I go for sample selection, what you can say about the possibility? No answer. Anyone? If I know the binomial distribution probabilities, by knowing these probabilities, can you judge what is going to happen in your sample?
So it depends on the standard error.
That I agree. Standard error is okay.
But sir, yes, on the whole, we can have a basic idea of where are things going.
Yes, in this example, which value you expected more often in your sample?
So
The
9.
9,
9.
10,
And
9.
9. After that?
10.
Then
after 7.
7. So where will be the concentration of your output? Your output concentration will be
7 and 9.
7, 8, 9.
Yes.
Isn't it?
Yes.
Others are much, much smaller. So if you look the probabilities also, you can see that more the probability that event will happen in your sample. Do you follow the last sentence? Prior to sample technique, prior to go for sample selection, if I have a binomial model for my survey, based on binomial model, I will be able to judge what output very often will happen in my sample. Histogram also say the same thing. Table also tells you the same thing in my case. Probability also tells you the same thing. Yes, clear?
Yes, sir.
Yes, sir.
Yeah. Now, I'm going to explain you a very work I have done for a poultry farm. Very long back, when I was working in Ferguson College, one of the poultry farm had a problem. They asked, sir, I want statistical help for some business. Can you help us? I said, yes. Everybody should understand this. That is the last work today. How binomial distribution helps to explain a real life research. So I will be explaining you a research problem. Attentive. Any question if you have, you can ask. The poultry farm manager states that an egg damaged at the destination after transportation is 0.23. A tray has 6 eggs. $500 such trays are transported. A research topic is classify them with say W with W equal to number of eggs damaged per tray. This is the research topic. This means W equal to 0, 1, 2, 3, 4, 5, 6. What are the frequency of trays? Any question on the research? How many of you follow the topic? Any question? There will be a tray, one tray. One tray has 6 eggs. One egg damaged, probability 0.23. Such 500 trays are transported. Classify them. That means this is what my research area. This is what my research area. This is binomial model because each egg has success equal to not damaged with 0.77 probability and damaged with 0.23 probability. And a tray is binomial with n equal to 6. So to get the answer of frequency, I'm doing the R package. I'm doing R package. W P 0 1 2 3 4 5 6. W binomial probability. P binom 6. Sorry. W 6 comma 0.77. Because W denote W denote number of X damage. So the probability will be 0.23. Or if you take success as not damage. So I will take the probability 0.77. Oh. This is what the probability for damaged egg per tray. Can anyone tell me, among 500 trays, how many are having 0, 1, 2, 3, 4, 5, and 6 damage? What is frequency now? Zero damaged, 1 damaged, or 0 not damaged. 1, 2, 3, 4, 5, 6 multiplied by 500. See the frequency now? See the frequency. Zero. Zero. What do you mean by zero? W is the number of X not damaged per tray. So 0 not damaged means all are good. That is a small probability. One not damaged, these many trays. 2 not damaged, these many trays. 3 not damaged, these many trays, and so on. So this represents frequency of trays. I can plot a graph. I can plot a graph. So this way, we can have sample analysis if we know probability model for the sample. I am repeating. One tray. You can note down in the notebook if you wish. One tray. One tray has 6 eggs. Each egg damaged with probability 0.23, not damaged 0.77. So not damaged is P 0.77, 1 minus P 0.23. Such 500 trays are transported. Find out how many of them have 0 not damaged, 1 not damaged, 2 not damaged, and so on 6. You cannot open all the 500 and check it, time consuming. But you know, each tray is a binomial model. Multiplied by such 500 will give you frequency. That is what I have done. Or instead of histogram, you can have a better graph. Plotting. Plot frequency on y-axis and W on x-axis. देखो. All 6 are good, approximately 100. 5 are good, that means 1 damaged per tray is high. And so on. So lesser will be the complaint that the customer will give. Because out of 500, 104 trays are having no damaged egg. Approximately 187 trays are having no 1 per tray damaged. Similarly, 139 and so on. And more complaint will be for 0, 1, 2. Therefore, binomial distribution is a probability distribution that helps. Binomial distribution is a probability distribution that helps for classification of the sample data. If the binomial distribution assumption satisfies, it classifies the analysis output. Of course, I will be repeating this in next class also on Wednesday. And before I close for today's class, let me see how many of you can answer properly. Rohit Podar,
Yes, sir.
do you follow the last research objective?
Yes, sir.
Can you explain me?
Yes, sir.
Ah.
So there was you took the research was on eggs, like how many will be not damaged when there are 6 eggs in a tray and there are total 500 trays. So
Yes.
for just a second,
What
sir.
statistics does in this work?
Sir, binomial distribution, because the probability of damaged and not damaged is fixed for
Yes.
every egg.
Yeah.
And since there is a sample of total 500 trays.
Yes. Yes.
The model was binomial.
Okay. Do you follow very well how to compute the answer?
Yes, sir.
Okay.
So should I tell?
No, let me ask someone else.
Okay, sir.
Gopala Krishnan.
Yes, sir. Gokul.
Do you follow the last work?
Yes, sir. Somewhat I've got it, sir.
Try to explain your understanding. What is the objective of this?
Sir, we are basically trying to calculate how many eggs would not be damaged in a tray, the probability of getting it. So what we got is that the probability of getting 5 eggs not damaged would be the highest. And then the frequency that we have calculated gives us the number of trays in which 5 eggs would not be damaged, 2 eggs would not be damaged.
Very good. Very good. So did he open each tray and check or used binomial distribution?
So binomial distribution.
Perfect. So by this research problem, what do you say about probability model? How probability model helps you?
So it helps us to get the estimates without practically doing, without practically experimenting.
Yeah. Before you go for sampling, before you go for survey work, before you go for research, if the objective is clear, by statistical model, you can estimate what is happening in the future sample. Correct now?
Yes, sir. Yes, sir.
Yeah. Sani Kamble. Sani Kamble.
Yes, sir.
Do you follow the last work?
Yes, sir.
Can you explain me?
So we found 500 trays which are not damaged.
Yes. So what is that 0, 1, 2, 3, 4, 5, 6 tells?
This is the not damaged tray.
Yes. So finally, what is the objective?
We find the binomial distribution.
Okay. Okay. Now, Akshay Garde,
Sir.
do you follow the last one?
Yes, sir.
Tell me what is it.
Sir, we have to find non-damaged eggs in each tray. There are 500 trays. Hello.
Yes. Tell me.
Yes, sir. There are 500 trays, and we have to find non-damaged eggs in each tray. So we find a frequency in 1, 2, 3. Means in each tray 1, 2, 3, 4, 5, 6.
0, 0, 1, 2, 3, 4, 5, 6.
0, 1, 2, 3, 5, 4, 6.
Okay.
And
So what is why I have explained you this model?
Sir, to find means to use a binomial distribution in a real life example.
Very
then
good.
then practically observing.
Okay. Balaji Bahirwal. Balaji Bahirwal.
Yes, sir.
Do you follow the last example?
Yes, sir. I follow it.
Can you explain me?
Sir, we have used binomial distribution for real life problems. We have used a poultry farm example in which we have tried to find the number of eggs in each tray which are not destroyed, damaged.
So the final answer gives what?
So the 0 eggs which are not damaged is 100. The trays in which only one egg is damaged is 186, and the trays in which more than 4, 5, and 6 eggs are damaged are few ones.
Yes. So in case if probability model is known before survey work, what it helps you? How it helps in survey work?
Probability model helps us to estimate the results before sampling.
Yeah. You can judge about what is going to happen in the sample, correct, na?
Yes, yes, sir.
Yeah. So anyhow, we have to repeat this type of example in the next class again. And you will realize the following. Probability model tells us, probability model helps us to speak about what is going to happen in the sample, and accordingly, we can modify sampling method for better result. Once the eggs are packed, very difficult to reopen and check damaged or not. So, probability model called binomial distribution helped for classifying the trays with the help of either damaged eggs or not damaged, either of the two. If you get the classification for damaged egg, 500 minus that will be the not damaged. So today this is enough. And Wednesday class, the same example once again I will be explaining. And then one more real life situation where binomial distribution will help. Meantime, practice today's class either by reading from the book or by the videos. Either clear? Any question? If there are no questions, okay. Today I stopped. Goodbye. Have a good day.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.